So I welcome you all for a data structure lecture. Today's lecture, we're going to see about what is the definition of data structures, what are the real-time applications of data structures, and what are the data structures available with an example. Okay, so we move for an presentation. Introduction to data structures. So what is a data structure? A data structure is a scheme for organizing data in memory of a computer. So today's in real world applications, we mostly deal with the data. So data plays a major role in today's world. So handling the data is mandatory, organizing the data and retrieving the data whenever you need it. So we need a data structures. We defining a data structure is organizing data in the memory of a computer. So some of more commonly used data structures are list, arrays, stack, queues, heap, trees, and graphs. So list, array, stack, queues, heaps, queues are belongs to linear data structure. Heap, trees, graphs belongs to the nonlinear data structures. This is another definition. The way in which the data is organized affect the performance of a computer for different tasks. Okay, so most of the computer programmers decide which data structure to use based on the nature of data and the process need to be performed on the data. Okay, so for any kind of application, first we must understand the problem. If you understand the problem clearly, based upon the application, you may choose the different data structures because all the data structures will not suitable for all kind of applications. Based upon the difficulty of the task and complexity of data, we may choose a different kind of data structures. So we go with an example of queue. A queue is an example of commonly used simple data structures. Queue is beginning and end, called a front and back of the queue. So generally, the normal queue, we form a queue. So those who are present in front of the queue served first. So that is front. End of back is end of the queue. Okay, so first come first serve basis. Data enters the queue at one end and leaves at another end because this data exits the queue in the same order in which it enters the queue. So like people in a checkout and line at the supermarket. So another example of a nonlinear data structure is called binary tree. A binary tree is another commonly used data structure. It's organized like a upside down tree. So like a hierarchical representation of data is called a tree. Binary tree have not more than two children. Have two children or one children, not more than two children. So that is the concept of binary tree. Each spot on the tree called node. Here every thing, see here, this every is called as a node, holds the item. The node, each and every node hold the item of the data along with the left pointer and the right pointer. Left pointer consists of the address of the left subtree node, and right pointer consists of the address of the right subtree node. Then the pointers are linked with the structure forms upside down tree with a single node at the top called top root node, and branches increasing on the left and right as you go down the tree. Choosing a data structure. So we saw the two examples belongs to one is a linear and another one is a non-linear structures. Choosing a data structures is a major role. So in last slide we discussed based upon the complexity of an application, we may choose a different kind of data structure. So choosing a data structure plays a mandatory role by comparing the queue with the binary queue with that binary tree. You can see how the structure of the data affects what can be done effectively with the data. So we discussed the previous two example about the queue and the binary tree. See the structure of the data and operations going to handle. Okay, both are very different manner. A queue is a good data structure to use storing the things that need to kept in order, such as a set of document waiting to be printed on a network printer. So printer is the best example to expose about the queues. So if you give a print as the first document, that will be print. So nth document will print after completing n minus 1 document. Okay, so good data. So for printer application, they are using a queue data structures. then the job will be printed in the order in which they are received. The most network print servers maintains as a print queue. Then choosing a data structures as a binary tree is a good data structure to use for searching stored data. Okay. Uh, Binary search is most related with the binary search tree. So best searching operations, we need a binary trees. The middle term from the list is stored in the root node, and the values less than the root node is all present in the left side of the tree. The values greater than the root node, all the values is present in the right subtree. A search engine begins at the root. The computer either finds the data or moves left or right. So depending upon the value for which they are searching. Each move down the tree cuts the remaining data in the half. If suppose I'm going to search a tree, search a value, most minimum value among the tree, that should be present in the left subtree alone. So it keep the root node and only travel in the right left subtree. The entire right subtree is skipped. Okay, it will search only one half of the tree. That is the best searching example. Items can be located very quickly in a tree. Telephone directory assistance information is stored in a tree so that name and phone number can be found quickly. Okay, the telephone directory is the best example to representing a binary tree. For some applications, a queue is best data structure to use. For other, a binary search tree is better. The programmer chooses from among the many data structures based on how the data will be used by the program. Okay, so data structures in Alice. Alice has two built-in data structures that can be used to organize the data or create other data structures. We chosen two important examples, that is list and arrays. So see this picture, have a list, the list and arrays. Arrays are a continuous manner. One will be depend upon the other values. So the location, this connection is a location. This address is first address is one, first member is in the address 1000 means if it is an integer array, second will be stored in 102, next 104, 106, 108. So here the addresses are connected. Okay, data may be different data, but addresses will be linked together. Then list, no need of connection with the addresses. So there is a gap, but the gap representing there is no connection between addresses. So this is the primary difference between an array and list. See, a list is defined as ordered set of data. It is often used to store objects that are to be processed sequentially. A list can be used to create a queue. List can be used to create a queue. In arrays, array is indexed set of variables such as danger 1, danger 2, danger 3. Here the name of an array is danger 1, 2. It's like a set of boxes that holding the things. A list is a set of items. An array is a set of variables that each store an item. Set of variables, so each store an item. Array and list. You can see the difference between arrays and list which you delete items. So see, consider the list before deletion, you have like this. Here we going to delete this red color. Okay, we're going to delete the middle element, mid of the persons. The after deletion, it looks like this. Because there is no contiguous memory allocation in a list. But in arrays, so after deleting the red color dress, here the gap is formed. You want to fill the gap. So you want to fill the gap either moving, we want to move the data present after the deletion should be moved one step forward. See here. In array in a list, the missing spot is filled in when something is deleted. Okay. But in case of array, an empty variable is left behind when something is deleted. See here. So you want to move one step forward this two persons here. So a list is created in Alice by checking the make list box when creating a new variable. So make a list box here. So for all in order and for all together tiles can be used to store the list. They are at bottom of the editor area. So arrays can be created in similar manner, but more often they are created using the array visualization object from the Alice local gallery. The array visualization object has special properties and methods for manipulating elements in an array. Yeah, Alice has a set of built-in functions that can be performed on array. Set of built-in functions. We're going to create it. Okay. So here, compared to list and arrays, some of the applications will support by array. Some of the applications can be implement with help of list. So in this lecture, we may differentiate the what is the linear structure, what is the non-linear structure, and how we can choose the data structures based upon the applications. And we discussed a few applications regarding this choosing a data structures, and what are the main difference between arrays and list. Okay. So in next lecture, we start up with the linear data structures, that is a linked list. So thank you for listening. In this, I'm conclude this lecture. Thank you.